So I thought it might be beneficial to have an extra explanation of Hamilton's rule and kin selection, and I'll pepper in a couple problems here. So I'll be doing these problems as I go, but you're also welcome to pause and do them on your own. In fact, I think that's probably the best strategy to go about this. R sub g times b minus c is greater than 0. So basically what this is saying is that if I'm going to incur a fitness cost to my own number of offspring, I should be able to help my relative produce an equal or greater, well, really a greater number of offspring when it's scaled by their degree of relatedness. So if I'm related to my relative by 0.5, I should be able to double the extra number of offspring that they have in relation to the number of offspring that that effort is going to cost me. If the benefit I can provide to my relative's offspring, scaled by how related they are, outweighs the cost to my own number of offspring, then selection will be favoring the traits that cause me to help my relative over myself. So this is really the equation that helps to assess whether or not altruism makes sense. And I put altruism in quotation marks because altruism is defined differently, but if there is an ultimate selfish motive, like kin selection, then maybe it's not actually altruistic. But in general, altruism is, in like the common vernacular, discussed as something you do for someone else without any expectation of the favor being returned. So in this case, this is kind of deciding whether or not it makes sense for example, a helper at the nest to help the parents raise the offspring, or for someone to help their siblings raise offspring. So let's say you decide to not get married and instead help your brother and his wife raise their own children. And you figure that had you gotten married and had your own children, you would probably have had 4 children of your own. Now, this is a very contrived scenario, and also humans don't really work like this, but for the sake of argument and practicing, bear with me. So you just gave up 4 children of your own. You're not going to get to have them. How many extra children should your assistants help your brother to raise and his wife in order for this decision to make sense according to Hamilton's rule? Rg times b minus c should be greater than 0. So you share 50% of your genes with your full brother. And let's hope that you don't share any genes with his wife. So she's kind of out of the equation here. Any help you give your brother should really then result in more than twice as many offspring as you could produce with the same energy, because 50% times 2 is 1. So if you work through the algebra here, you're related to your brother by 50%. Your benefit to your brother's offspring is b, and you are losing out on 4 offspring. So if we work this out, we have 0.5 times b is greater than 4, moving the 4 to the other side. B should be greater than 8. So really 9 offspring you should be helping your brother to reproduce. So I guess they're going to have their hands full in this very contrived situation. Notice that we're looking at the benefit to the brother and the relatedness to the brother. Whoever's getting the benefit is going to be where you're calculating that degree of relatedness. So your brother's offspring and your own offspring are the number we're talking about here. So what about if you help your parents? So this is kind of like the problem we went over in class. If you've also got a cost of 4 individuals to your own reproduction, it might seem like the answer would be the same as when you were helping your brother. But this is where it gets tricky, because notice that you're helping your parents, plural, and you're 50% related to both of your parents. So really, you're helping two individuals, both of which share 50% of your genes. So we kind of have to put another term into here for another RG times B. So you're 50% related to your father, and you're 50% related to your mother, minus the cost to you is going to be greater than 0. And since the benefit to your father is going to be the same as the benefit to your mother, we're just going to combine those two terms and say 2 times 0.5 times B mother, father, minus 4 is greater than 0. And really this boils down to the benefit to both of your parents at the same time should be greater than 4. So because both of your parents are benefiting, we have to add that second term. Notice that you need to be greater than 4 for this decision, or the behavior that would lead to this decision, to get selected for. If it's equal, there really isn't going to be any selection one way or the other. The other thing I want to point out here is that since you're helping your parents reproduce, it might be tempting to look at the relatedness of the offspring they're going to be reproducing. But notice that your relatedness factor needs to match to who's getting the benefit. So you're 50% related to your father and your mother, and the benefit is going to be in terms of their offspring. The cost is going to be in terms of your offspring. So let's say you're a young male lion and you have two choices. You are looking to join a coalition to take over a pride of lionesses, and you can either join an unrelated male, control 3 lionesses with whom you will collectively sire 6 offspring per year. So you'll get 50% of that paternity. Your other option is to join your father and his brother, so your father and your uncle. And together you could take over a pride of 8 lionesses, but they'll probably only produce 12 cubs a year because there's, well, 1 extra mouth to feed, yours, in that coalition. And you've also got no paternity. All of the paternity will go to your father and to your uncle. So let's take a look at then what these calculations would be like. So first off, I encourage you to stop right here, pause it, and just do this math on your own. Gonna wait for you. All right, let's begin. So let's do the first one quickly. Hopefully this is straightforward. So you're not related to this guy. So any offspring that he sires, which is going to be 50% of 6 or 3, you won't get any inclusive fitness. The other 50% will be just simply 0.5 times 6 equals 3. So that option would give you 3 total offspring. Let's look at what happens when you decide to join your uncle and your father now. And now let's assume that these 12 cubs are split 50-50 between your father and your uncle. So we've got the relatedness factor times the benefit to the offspring of whoever you're related to, minus the cost to your own number of offspring, and I always write equals here. Really, we're going to want to maximize this. So we want this to be greater than 0. Or if we rearrange this, it's really saying the relatedness times the benefit to your offspring should be greater than the cost to yourself. And in this case, those traits that form those behaviors are going to get selected for. So we really now have 2 relatedness factors and benefits that we need to include here. We've got RGB uncle and RGB dad. And you are going to be 50% related to your dad. So we're going to do 0.5, and then he's going to get half of these cubs, so times 6. And then we also need to figure this out for, oh, I guess I just did your dad. We also need to figure this out for your uncle. And so he's going to be a quarter related to you. And he will also have 6 offspring. So the total inclusive fitness, or the benefit to your relatives, is really going to be 3 plus 1.5. And you can already see then that minus the cost of potentially 3 of your own offspring is going to be 1.5. This is going to be greater than 0. And so this trait will be selected for. It'll be favored. If you're going to try to maximize your fitness, you should choose this strategy. So you guys got pretty good at calculating relatedness. I'm just going to go through a few of these relationships so that you can review these on your own. So anytime you have a daughter and a mother, that's right, you should be thinking 50%. Anytime you've got a son and a grandmother, how much are they going to be related? Pause it here if you don't know yet. They're going to be related 25% because you've got 2 links, one to the mother and one to the grandmother. 50 times 50% is 25%. Let's see here. If you've got well, let's go to the interesting case right away. It's tough to find other less interesting cases here. So Charles II is sort of renowned for having been the product of inbreeding. He had some physical deformities, and it's thought that that might have been the result of recessive traits coming through as a result of inbreeding. So let's try to figure out how related Charles II is to his father. Now, take note here. He's the son of Philip IV and Mariana of Austria. Philip IV is the son of Philip III and Margaret. And Mariana is the granddaughter of Philip III and Margaret. So if we want to figure out how related Charles II is to his father, well, first we're going to need to figure out how related his father is to his mother. So anytime you have a father-son relationship in a diploid organism, you're going to simply have a 50% relationship. So he is at least 50% related. And it might be beneficial to kind of draw this out. So if this circle represents all of Charles II's genome, this portion is going to be shared with his father. This portion will be coming from his mother, and let's take a look at his mother. So Philip IV is the son of Philip III, so we might even just draw him up here. And that makes him the brother of Maria Anna. So you've got 50% here. That also makes him the uncle of Mariana. So remember, uncle, niece, nephew relationships are going to be 25%. So what this means then is that Philip IV gives 50% of his genome to Charles II. Mariana gives 50% of her genome to Charles II. Now, because she is 25% related to Philip IV, 25% of the genes on average that she gives to Charles II are also going to be shared by Philip IV. So she only gives 50% of her genes to Charles II, but 25% of that 50%, or 1/8, is going to be also shared by Philip IV. So essentially we end up with this father being 5/8 related to his son Charles II. What does the relatedness of a female worker be to her sisters, to her brother, and to her parents? I wouldn't ask you to explain exactly why the relatedness is what it is on an exam, but I do want you to know how related they are in this haplodiploid system. I want you to know that because I think it's such an elegant example of Hamilton's rule at work in a system that is very unlike ours. Even though they're not diploid, Hamilton's rule is at play and helps to explain some behaviors. So I'll let you pause it, see if you can remember this. And 3, 2, 1. Sisters are related to each other by a factor of 3/4, and that's because out of their diploid genome, they get the same DNA from their father. Their father only has one complement of the genome. He's haploid, and so they both get the same haploid sperm from their father, and then from their mother, they're going to share on average half of a half or 1/4 of their genes. So to her brother, she's going to only share 1/4 of her genes. And this is because of her diploid genome. Her brother is not getting any of the gametes from her dad. And her brother is only going to be coming from the mother. And so just like in this case, from that mother, they're going to share on average 50% of the remaining 50% of her genome, or 1/4 of her genome. And then to her parents, so she's got a diploid genome, and her mom has a diploid genome. It's going to be 50% to her mom, and to her dad, half of her genome also comes from her dad. So all of the dad's genome will be in her, but half of her full genome is only going to come from her dad. So the parental, or her relatedness to her parents, is going to be 50%. So this helps to explain that behavior because in honeybees, we see what you might call altruism, or giving up all reproductive success for the sake of the colony and really helping to get those sisters reproduced, because any future princesses that get reproduced are going to benefit her inclusive fitness even more than if she was laying an egg herself. In some cases, when workers can lay eggs, we see basically this assassination, and sisters end up killing their mother because ultimately when they lay an egg, they're going to take their diploid genome, pare it down into 1/2, and they can produce males then that carry half of their genes, or really all of the DNA in these males comes 100% from them. Regardless, they carry much more DNA than they would if they were helping to raise their male brothers. So they're only 1/4 related to their male brothers, and they get to, if they can lay an egg, they get to realize a little bit more fitness. So this is how related they are, and that was my explanation of why this helps to explain why we have eusociality.